Hello, my name is Joseph Little. I'm the Programme Chair of the MSc in Building Performance Energy Efficiency Design, which we teach in the School of Architecture, Building and Environment in TU Dublin. I'm here to talk to you about the programme, its structure, its value, and a little bit of what you might explore when learning. So it's the head of discipline is Kirk McCormick, and at the moment, like I said, I'm the program chair. I love this first image because it kind of makes that connection between climate change, activism on the street, the things we need to do, the way we need to change our society, and then the way that we're actually going to achieve those changes, which for the most part is actually through standards, more careful specification, super low energy buildings, and more engagement with building science in our technical designs. So there's a whole cascade, as you know, of treaties and policies coming at us every day. They're coming from the United Nations, they're coming from the UN. They're asking us to do extraordinary things. They're checking, are we doing enough? Have we missed something? Is there more we can do? The Climate Action Plan, the Irish National Climate Action Plan, with extraordinary figures like retrofitting 500,000 homes to B2 by 2030, which is 5 years away at this point, installing 680,000 renewable energy heating devices. I mean, really, really challenging, extraordinary ambitions that we do need to achieve or something very, very close to. And that requires a massive upskilling, technical transformation in our building design skills. So there again, housing for all. And again, we're hearing about it in the newspaper almost every week. How many houses do we need? Are we meeting it? Why are we not meeting it? What can we do? But in the background is always this supposition, this understanding that we know what we're doing in building design offices throughout the country. Architects, engineers, architectural technologists, building physicists, building energy rating assessors, BER assessors, material suppliers, etc. That we all have the upskilling that we need, that we know how to deliver on these ambitions, and that's all in hand. And very often, as we know, that's not true. We've still got lots and lots of technical upskilling and learning to do to meet these ambitions. We know about roadmaps coming from the likes of the Irish Green Building Council in terms of setting out an initial vision for decarbonisation of Ireland at the construction sector. We know about the Climate Action and Low Carbon Development Amendment Act from 2021, which was 6 or 7 years after the first Carbon Act. And this was the first time in Ireland that the government put in place sectoral targets for each different sector: residential, commercial, housing, agriculture, food, all the different sections of our society, and the kind of carbon changes that they needed to make to meet this overall national plan. And then even accountability, oversight, strengthening annual visions. So really, really significant documentation for the first time, which is independent of any one government body, any one political party, but something that we in Ireland say we will achieve this. And this is in concert with other countries across Europe, of course. So in all of that, we then have guidance to help us reach these targets. And there's some lovely guidance out there from kind of different sources. This one I love, the Bristolian solid wall guidance from quite a few years ago at this stage, but really good guidance for energy efficiency retrofit of historic buildings, what to do and what not to do. National Standards Authority, SR 54, which has been revised a few times and, has great guidance in some areas, but, maybe not quite as good in others. We've got the technical guidance documents, which are underpinned by the building regulations, of course. And again, kind of a mixture. And how do we navigate these? What's actually being asked for and what's not? The Royal Institute of Architects of Ireland, our Engineers Ireland, other bodies providing guidance from a professional perspective, in this case, sustainable design pathways. We've got the climate challenge from different bodies, the RIBA in the UK, the RIAI in Ireland, again, Engineers Ireland, all sorts of other different bodies saying we need to do this thing and this is what we think progress and positive action looks like. So it's fantastic, it's exciting, it's a bit scary at times, but in all that, there's kind of general agreement that we need urgent action and leadership, and in this case by architects in the wider construction industry. As professionals, we have solutions and we want to play our part in addressing this emergency and to collectively rise to the challenge. So for that to happen, we need to know how to do that. So in all of these cases, those policies and guidance documents will be poorly applied or incompletely applied if the knowledge and skills required are still uncommon and the means by which professionals can upskill while in full employment are not available. So this is especially so given the step change in standards that we're talking about and the limited time available. So to remedy this, Dublin Institute of Technology and now Technological University Dublin innovated back in 2011 and again in 2015 and again in 2017 to create programs that met those gaps and addressed those shortfalls in knowledge. The innovation was the creation of masters focused on professionals, building professionals, and I suppose all building professionals, the groups I mentioned earlier on, and not just, for instance, architectural technologists. So we created an MSc in building performance in 2017. That was the last of those innovations. The graduates of the MSc will be qualified to apply relevant principles of building science and calculation, make critical judgments within a changing and ill-defined technological context. And we should acknowledge that the context we're in right now, which is changing and at times ill-defined, will probably continue to change and be ill-defined. We need to be able to operate effectively within that context, and to provide specialist professional technical services relating to energy efficiency, deep renovation, low carbon building design and sustainable buildings. And I think probably this is slightly overlooked at times, to provide leadership and engage critically in a collaborative environment. So all of those things are needed by building design professionals. They need that education, and we set out to provide that since 2017. So this is what the program structure looks like in an overview very quickly. Just to say, if you look at the bottom of the page there, we're talking about a nested program. So the postgraduate certificate is over 2 semesters, 1 year. The postgraduate diploma is over 4 semesters or 2 years. And the MSc in building performance is over 3 years and therefore 6 semesters. We call this a nested program. So each year there's an exit possible. At the moment in 2025, there is springboard funding, and there has been for a number of years, which is a 90% subsidy from the government, which is an extraordinary investment by the state in your upskilling. Right at this moment, I can't guarantee that that will continue, but it's obviously our ambition to provide that subsidy where we can. So if we look at that program just briefly across the 3 years, you can see a range of modules across, and I'm going to go through each of those right now. So if we start at the first module, decarbonising building design, it's kind of taking you through that. It's the, you can use my cursor, it's this module here, decarbonising building design. It takes you through a engagement with where are we in society, what's going wrong, what's changing, where the issues are, where the policy responses are, both at the level of the United Nations, the EU and Ireland. What are the technologies that can help us engage and address that? And then the technical skill that we teach in that module is around plane element calculation, basically U-value calculation, and an introduction to thermal bridge calculation and so on. But broadly, it's a policy and technology focused module that brings you into the space of the overall picture of where we are and where we need to get to. One above that there, reflective building design practitioner, is a module that goes through the whole year and encourages people to kind of reflect on their own learning journey, look at their own house, look at their own practice, and learn from the decarbonising building design practice of other professionals. So it's a kind of an interesting exploratory module. Going further, you then have 2 electives. You've got 2 options. Building energy modelling using either DEEP, the Domestic Energy Assessment Procedure, which is the statutory tool that's referred to in Part L2 of the building regulations, and is required to be used for new build buildings, and then is used to guide compliance and grant aid for the retrofit of domestic buildings. And then the other option that plays off against that is PHPP, the Passive House Planning Package. And again, this is teaching the world's leading non-regulatory super low energy building standard for both new build, retrofit, domestic and residential and non-residential. So that is a module that we've been teaching, and we've had collaboration with the AECB in the UK for that, the Association for Environment Conscious Building, because they don't have a course like that in the UK and they find it exciting, and I'll talk to you more about that in a moment. The next, coming after Christmas, hydrothermal risk assessment, we teach 2 tools, BuildDesk U, which is effectively relates to the dew point method, our standard, the Glaser calculation, to put it briefly, which is quite common. It's the main tool for risk assessment, moisture risk assessment in the world, but it is very, very limited. And therefore we teach WFI Pro, which is a significant improvement, both in accuracy and allows proper parametric risk assessment for both new build, retrofit, every type of building and so on. So again, we provide access to the software standards, etc. The next tool we teach is called Mold Simulator. So this is a thermal bridge calculation tool, which teaches 2-dimensional thermal bridge junction. So the junction between plane elements, how a window meets a wall, how a wall meets a floor, and the additional the extra overheat loss that can occur at those locations and any moisture risk associated specifically with those junctions. So really useful, and has helped people in the past move forward and join the National Thermal Modelers Register, even though this is an introductory module. It's not a module of the scale associated with that, but I know some people have come through and been able to take advantage of that. But like all these other tools, they're tools for technical design offices, architects' offices, building designer offices, where they need those extra skills without necessarily becoming a specialist. So that's first year. Moving into second year, building environmental assessment methods, where we're learning HPI, the Home Performance Index, which was designed, created by the Irish Green Building Council for residential buildings and mostly apartment buildings, but it can be for housing estates, etc. And it's occasionally used for retrofit. And it addresses that wider concerns about, is this building in the right location in the first place? Is this neighborhood walkable? Water supply, biking space for parking your bike, access to facilities to clean your clothes, a whole wide range of environmental concerns, including embodied carbon and operational carbon and energy, of course. And then the LEED, LEED, LEED Platinum, LEED Gold, etc., is the tool that we use for non-residential buildings, and that reflects the importance of foreign direct investment in Ireland. So both of those tools are taught in a single module, Building Environmental Assessment Methods. Quite excitingly, we then teach a module on circularity. So building circularity, how we can keep buildings, building products and building materials in use for as long as possible through repair, reuse, refurbishment, repurposing, remanufacturing, etc., and thereby have as low as possible an impact on the planet. So One-Click LCA is a life cycle assessment tool that enables us to do that. And then we also teach building design for circularity, which is a fascinating new emerging area as to how to actually technically specify buildings and particularly consider those junctions and how those materials come together such that they can then come apart better, to improve the ability for us not only to recycle materials, but also to reuse products and reuse components as much as possible. And thereby, minimizing environmental impacts. So very exciting module that. And then dynamic building energy modeling using dynamic simulation and the non-domestic energy assessment procedure, NEAP. For this, we tend to use Design Builder, and through that, we have access to an SBEM interface, which is used for NEAP. So this again allows us to look at overheating, air quality, comfort, daylighting, a range of concerns, and some amount of ventilation focus to overcome some of the concerns that, for instance, other tools don't go as far as overheating. And as we know, as buildings become more airtight, more insulated, concerns about overheating and comfort are coming to the fore to a greater extent. So dynamic modeling can allow you to do that, and Design Builder is an excellent tool to do so. So that takes us to the end of the 3 modules in second year, and then we move to the big project at the end of second year. So if we look at this slide here, you can see how there's an end of year project in first year. There's a much bigger end of year project in second year. Both of these are very much based on real buildings. They could be residential, moving on to non-residential or otherwise. That can change from year to year. And then in third year, you're moving on to a thesis, which begins at the end of semester 1 and moves on into semester 2. And really that's beginning to move into that kind of personal research question, that itch that you need to scratch. But certainly it's the first 2 years that we'd like to really encourage most building design professionals to engage with. The first year might be subsidized, but the first 2 years really complete that technical upskilling, that transformative technical upskilling that we're so passionate about. The next thing to say, obviously, is also that as you go through the 3 years, your capacity to do research and to lead in industry is also increasing. Finally, just to say that there are CPDs. At the moment, it's 3 CPDs, but it may be growing to 4 CPDs, or micro-credentials, to use emerging language, where over 6-week periods, a building design professional can engage in one of these modules and significantly transform their skills in that particular area. All of this is obviously provided online and is very, very accessible, as well as good value. There's obviously more on that on the website. In terms of how we deliver, we use a mature virtual learning environment called Brightspace, where we provide all of the resources that are needed by the student in their time with us, including all standards that are needed, exemplars of past student work, recorded video lectures, links to webinars, a discussion kind of discussion page and so on. So you get just some screen grabs here that kind of give you a sense of that. So there's the module site, the virtual learning environment for one of the modules, but there'll be obviously a number of these considering how many modules there are. There's an example of a video lecture where you'd be clicking to start. You can watch us as many times as you want, and you can slow us up and speed us up, and you can slow us down. It really assists deep learning. That's then tested with assessments, and you can see a screen grab there of some of those. That's the discussion board you're seeing there, where students can post about just things that they're confused about, things they want greater information about. And we really encourage students to support each other, student to student engagement, as well as from lecturers. And then you've got your live webinars. So by providing the lecturing content and then giving them access, the students access to discussion boards and to webinars, and of course then with there's two small exams and there's a completing project in the typical 6-week modules, you're getting really fantastic deep learning that's provided with excellent feedback. So if I looked for a moment at a typical 6 weeks, to give you just a sense of what that might look like. In the first week, you can see there in orange, and we're typically running from Friday to Thursday, which is unusual, but it means that Friday, Saturday, Sunday, Monday, which are often when people feel they may have the best chance to upskill in their week, whether that's home time or office time, whatever, we provide people with about 3 hours worth of recorded lectures and a formative exercise to fill out, which challenges them. It's like homework, challenges them on the learning that they're seeing, test their knowledge, and maybe allows a kind of a deepening of that knowledge. On the Tuesday then of that week, there's a webinar where there's a live demonstration of the questions you were being asked, which might include review of the use of a particular simulation tool or some knowledge. Your questions can be posed and answered and so on. And then that happens again in the second week. And at the end of that second week, there's a small multiple choice questionnaire again in the evenings. This is all happening in typically in evening time to reflect fully employed participants. And there's a multiple choice questionnaire, which may or may not include the use of a software tool, because there's a lot of technical software tools that we're teaching over the year, the use of them, the standards based use of them. And then that's reflected again. We go back to that pattern for week 3 and week 4. So you've got the second exam. So the first exam is looking at the first 2 weeks and the second exam is looking at the next 2 weeks. And then we move into a project mode. So we've provided a brief to you to challenge you, and it's the blank sheet of paper, which is often a different thing, to use the analogy, rather than saying one of these 5 answers is right, which one is it? So it's challenging your knowledge in a different sort of way, based on a brief. The project is a full week given. In fact, students can start earlier if they respond to the brief beforehand. They then submit a draft unfinished submission on that Thursday of the 5th week. And then the following day, which in this case is the start of the 6th week, we then come online for the afternoon for a feedback session where we look at a range of different submissions that have been made and draw from them what's positive, what could change, what's really exciting, deepen the understanding of the brief through discussion about that and so on. And we give people pointers to how they might finish their project, and they've a further week to do so. And then, as you can imagine, whether it's the following Friday or even maybe the Saturday or Sunday, if we give an extension to it, people have got that extra time to finish that project, ensuring that you've got the really best project you possibly could based on really good feedback and time for reflection. We then grade those and we give further written feedback on those projects. So really over the 6-week period, plus that additional feedback, there's a really excellent opportunity to gain a significant boost in your technical knowledge and application of this area of calculation, simulation, technical design. And there can be student gatherings at different stages. Second last slide, just a bit of feedback from students who've taken part in either the CPDs or microcreds or the full year courses. It's a great course, and I love the way the course is structured, delivered online and tailored towards working professionals. That's the whole point. We try and make this as easy as possible, where it's real learning, it's difficult, it's transformative, but it's accessible for busy building design professionals. Then Aoife says, I've thoroughly enjoyed my year's study. I believe it's made me a more meaningful, a more mindful, knowledgeable technologist using energy efficiency measures to the best of my capability. And then John said, congratulations on an excellent course. Never in my life have I found a more useful course to deal with all the issues I come across in my everyday practice. It is brilliant. So great words there. Thank you. And there's my email address, joseph.little@tudublin.ie, or you can contact kirk.mccormack. That's McCormack, McCormack, kirk.mccormack@TU Dublin. So either of us, we're delighted to get in contact with you. And of course, there's more information on the website. Thank you.